We're going to go ahead and take a look at an application problem from section 10.4, which focuses on graphs of quadratic functions. So I'm going to go ahead and take a look at number 57 from your textbook. If you don't have your textbook near you, I would suggest pausing the video to go ahead and grab it so that you have something to read along with. Okay, so I'm going to assume that you have your book and you're ready. So 57 reads, if a ball is thrown straight up with an initial velocity of 48 feet per second, its height, which we're going to denote with s, after t seconds, so t will be time measured in seconds, is given by the equation s is equal to 48t minus 16t squared. Find the maximum height attained by the ball and the time it takes for the ball to reach that height. Okay. One other thing that we don't want to forget is that the units of measurement for the height will be in feet. So we don't need to graph this in order to understand the path of the ball. So if you think about it, if you went outside and you tossed a ball, it would take on something like, so let's say that this is you. You toss the ball, and then it will land on the ground. Okay. Notice that this takes on a parabolic shape, or a shape of a parabola. And in this problem, we want to know the point where it's highest at. So that would be your vertex. Okay, so your vertex, when you have a parabola that is facing downward, is going to be the maximum point, or the highest point on it. Okay. So one thing that I'm going to go ahead and do is I'm just going to rewrite the equation that they gave us. So I'm going to have this as s is equal to negative 16t squared plus 48t. And notice that it has that standard form, okay? If you need to, since we're going to identify A and B, if it makes you feel more comfortable being able to identify C, C is just 0 in this case. They don't actually have a term here for it, so it's actually just 0. That's why you're not seeing it. Okay, so in order to calculate T, I have my little shortcut of negative b over 2a. In other words, that's your missing butler and the two alligators in the basement, or the values in your quadratic formula that are outside of the radical. Okay. So I would identify b as being 48, and then a is going to be negative 16. If we went ahead and cleaned this up, this would be negative 48 over negative 32. Go ahead and either do the math in your head or defer to a calculator to help you finish off the calculation. And this is actually going to simplify down to a positive 1.5. And since we're talking about t, we're talking about this being 1.5 seconds. Okay. But note again, we want to find the maximum height of the ball attained and the time it takes for the ball to reach that height. So we've answered the time at which the ball is going to be at its highest point. Okay, so I know that from the moment it leaves my hand to the moment it reaches the vertex, this took 1.5 seconds to happen. Now I actually want to know the height of the ball. So in order to find that, well, if I know what t is, why don't I go ahead and put 1.5 in for it? Oops, that should be minus, my mistake, minus 16. And then 1.5 squared. Okay, so far so good. Because if I know what t is, I can plug it back into the original equation, and the only variable that is left over would be s, which is the height. So if I plug 1.5 seconds into the function, or into this equation, I will get the height value out. Okay, so if we perform this calculation, 48 times 1.5 is going to give you 72, minus 16 times 1.5 squared, which is going to give you 2.25. And we're just going to continue along with these calculations. 16 times 2.25 gives you 36. And 72 minus 36. is going to go ahead and give you 36 feet. So the ball at this point, so from the very top to ground level, this is 36 feet. This is the maximum height. If you select anything anywhere else along this path, you'll notice that it is a shorter distance away from the ground. So here are your two answers. At 1.5 seconds, the height of the ball is 36 feet, and this is the highest point of the ball's path.